Okay, 92 looks like 91. The problem for this, though, let me go back to that. It looks like the same problem. The problem is the region now. Whoops. And the region is this over here. Now, I want to go to a more accurate picture and explain to you why the region is so difficult. So what I want to do is just look at this over here. This is the region over here. I'm going to, sort of like put the lines down now for you. So this line over here is y equal 1/4 of an x. And this line over here is y equals, I think that was 4x. Let me go back and just, I know it's a lot of work down here. So I just was able to identify this. And I was able to identify, I said 4x, but it's actually 2x. Let me go back over here. Get my eraser out. And 2x, right? And then I got this hyperbola over here. And again, I'll go back to the notes, make sure I'm doing this right. I believe that was 1/x. Make sure that's down over here. And the other one was 4/x. And this over here is y equals 4/x. All right, I want to identify the points, and then we'll kind of slowly go through why this is so difficult. This point over here, right, again, it's nice to have a nice picture. You could probably identify what the point is by looking at it. But it's when 2x equals 1/x. I'll put this down over. When 2x equals 1/x. And I'm going to say that, looking at it, you'd get 2x squared equals 1, or x squared would equal 1/2, or x would equal plus or minus. Well, I'm in this quadrant over here, so I'm not too worried about it. Let me write this down for you. So it's going to be 1/√2. I'll put that down. Okay, let's get the y value. What's the y value going to be? You just plug it in. Where would you plug it in? Wherever you want. I'm going to plug it in here. Probably the easiest place to plug it in. You can get 2/√2, which is simply just √2. Let's do this point. Okay, what does that mean? 2x is equal to 4/x. What do you get there? X squared is equal to 2, or x equal plus minus √2, but I'm in this quadrant, so let's write this down. So it's going to be √2, and 2√2. Let's do this point. And what's that point going to be? It's when 1/x equals 1/4 of an x. What do you get there? 4 equals x squared. X equals plus minus √2, but we're in this quadrant over here. So I'm going to say 2. And what's the, that's going to be 1/2. Let's do this point over here. And that's when 1/4 of an x is equal to 4/x. What do you get there? X squared equals 16. X would equal 4 then. And what's the y value going to be? It's going to be 1. All right, so I know what the region is, and I'm going to shade that in for you now. And let me explain why this is so difficult to do. If I were going to use, rectangles go in this direction over here, I'd have to stop here. Because the top and the bottom, all of a sudden, when you get to this section over here, change. And I have another set of rectangles to do over here. So I'd be setting up 2 integrals now. And then finally, I'd have to set up 3 integrals. So I'd have to divide into 3 separate integration problems. Now, I'm not saying that's bad to do that. I'm just saying it looks like it might be a lot of work. Now, let's say you want to do it the other direction. You want to go in this direction over here. If you were doing that, going up here, it looks fine there. And then I'd have to stop here because the left and right are going to change. Then I have to stop over here. And then I'd be able to work my way up to the top. So no matter what I do, I have to separate into 3 separate integration problems. And I just don't want to go there. All right? So we have another way of doing it. Let me get rid of my ruler. And we're going to talk through that now. All right? So what we're going to talk through is, I got to go back to the original problem. Let me get my eraser out. We're going to use the Jacobian to do that. So I had to introduce some new variables over here. Now, before I do that, I want to kind of, look at these problems over here and just, so I'm going to say, y over x. I'm looking at the first equation, by the way, is 1/4. And then I'm going to look at this one over here. Now look at this one over here. Y over x equals 2. Let's keep going. And let's put, let me see which ones I've looked at so far. Let me highlight them. So I looked at this one. Whoops, I didn't start highlighting. I looked at this, and I looked at this. Let's look at the last two. And again, I'm trying to get x and y on one side. So I'm going to say xy is equal to 4, and xy is equal to 1. Here comes the tough part. We really got to, go from like the xy's to some other letters. And I'm going to say u equals y over x. And I'm going to say v equals xy. All right. Let's take a look at this, see if we can figure it out. And again, we're going to use the Jacobian, so you do partial derivatives, all kinds of things like that. But let's not worry about that too much now. I'm going to write down ux equals y. I'm going to take that, plug it in over here. There's a point to this, by the way. And v equals x times, well, y is going to be ux. And what do you get there? You get v equals ux squared. And now I can tell you what x squared is. I can tell you it's a relationship of v over u. All right, let's keep going. And I'm going to say that, I know I'm in the first quadrant, so I'm going to say x is positive. So this should be relatively easy to do. I'm going to say the root of v over u. All right, let's see if we can get the y in terms of u's and v's now. All right, so let's take a look at this. And so y equals ux, and x is equal to the root of v over u. Well, I think I can do that. Y is going to be the root of uv then. All right, this is important information, by the way. All right, so let's just, summarize what we did over here. We looked at a picture of it, and the picture really was, I'd have to separate it into 3 separate integration problems, and it looks like just too much work for me. I'm not saying it's impossible. I'm just looking to go someplace new, Jacobian. All right, so what I kind of looked at this thing and got a relationship, and I want to just go through that with you. And the relationship I boil this down to, whoops, I didn't mean to do that. This one over here, and this one over here. All right, let's go back over it, make sure it's written down for you. So y was the root of uv. I got that part down. And the x was this thing over here. All right. I did write that a little differently, but I'll tell you how I wrote that down. I wrote it down as v over u. All right. So let's go to this new thing, the Jacobian. All right. Jacobian is inside the absolute value. And what I got to do is, compute it. And someone says, it's really tough to compute that. And it can be. But I got to do this. And those symbols are partial derivatives. So I want to go through one step at a time. And let me write this over here. X equals, since I have to differentiate, I write this down as, v to the 1/2. And I can write it down as u to the minus 1/2. And I want to do, my penmanship is not good, by the way, I realize that. I want to do the partial of x with respect to the partial of u. And what do I do there? I'm really looking just at the derivative of u. And I'm going to say v is a constant here. So I'm going to say v to the 1/2 times, well, this guy's derivative, not that bad. It's going to be minus 1/2. And it's going to be u to the minus 3/2. And I also got to get the partial of y with respect to v. All right, let's write that down. So y is, I'm going to say u to the 1/2 and v to the 1/2. Let's write that down. So u is like a constant, and then times the derivative of v, which is going to be 1/2, and then it's going to be v to the minus 1/2. All right? And what do I got to do there? I got to do the product now. So the partial of x over the partial of u times the partial of y over the partial of v. Let's see if we can do that. So I get a quarter. I should say I get minus a quarter. And then what do you get? Let's see. The v would be v to the 0. And the u would be, let's see, u to the minus 2 over 2. So u to the minus 1. So that's going to be a u in the bottom. Okay? Okay. I just did this here. Now I got to do partial y, partial u. Let's take a look at that. That's going to be 1/2 u to the minus 1/2 v to the 1/2. Again, we're looking at this over here. I need to get the partial of x over the partial of v. Let's take a look at that. Again, we're looking at this guy now. What do you get there? Well, let's see, 1/2 v to the minus 1/2 times u to the minus 1/2. And what I got to do, I got to multiply those two together now. So it's going to be partial of y, the partial of u, times the partial of x, the partial of v. You get 1/4. That's not too bad. Let's see, you get u to the minus 1, which is 1 over u. And the v's would just, the exponents would sum to 0. So it's 1 over 4u. All right? So we just did both of these guys here. And all I do is I write them down now. Right? So what are we doing? We're writing this over here. All right? So what do we get there? We get, let's write this down. I get my eraser out because I'm pretty much done with this, kind of groundwork over here. We did our derivatives. I don't recommend doing those in your head, by the way. Now, of course, I need to add this together. So minus 1 over 4u, minus 1 over 4u. By the way, that's a determinant. And what do you get over there? You get minus 2 over 4u. And that's going to be, let's see, minus 1 over 2u. But I need to take the absolute value of it. So I get something pretty simple. I get this over here. All right? So what do? I got to write this down. All right? And let's put that down for you. So I got this integration problem. And let's go for it. It's going to be e to something. Let's not worry about that yet. All right? And I got to put the dA down, and it's going to be 1 over 2u. So I'm putting this down over here. It's this thing right over here. So 1 over 2u du dv. All right. Okay. I got to do this now. E. I'm hoping it's going to be easy. Now, I'm looking at minus xy. I got to look back over what we wrote down before, and it's there for me. So minus xy would just be minus v. And that's going to be over 2. All right, let's not worry too much about that. Here comes my problem now, is getting back one step at a time, the U's and the V's. U's come first, all right? So what am I gonna do over here? I gotta remember, let me get my eraser out. I'll start to erase things I don't need anymore. I need the limits of integration. And I gotta go through it carefully, all right? So let's do the U's first. And remember I said U was equal to y over x. All right, and let's just take a look at that. So where did I get that from? Right over here. Let's write this down. So y over x is equal to 1/4. That's right here. The other one is going to be y over x is equal to 2. So u is going to be 1/4, and then it's going to go up to 4. I'm sorry, to 2. Let me write that down. So 1/4, I just forgot what I said, up to 2. Okay, next up, I got to do the V's now. And remember what we said. We said that the V was xy. So I'm looking at this over here. Let's write this down. xy is 4, and xy, whoops, is 1. So I'm going to say it goes from 1 to 4. Okay, can we integrate that guy? And, you know, what I'm pointing out is that, you know, you're integrating basically this thing here first, the du. I want to put that down for you. It looks like it might be tough to do, but I don't know. Not really. What is it? It's going to be, you know, you'd get e to the minus v over 2. The 2 would come out. You'd be left with 1 over u. What's 1 over u when you anti-differentiate? It's the natural log of the absolute value of u. The limits of integration of that are going to go from 1/4 up to 2. And I need to evaluate that now. So what do you get? E to the minus v over 2. This is over 2. And then it's going to be ln 2 minus ln 4. I'm sorry, 1/4. Sorry about that. All right, I got to figure that out. So it's going to be equal to e to the minus v over 2. That's going to be ln 2. And it's going to be now plus ln 4. What does that give me? I forgot the 2 over here. It gives me e to the minus v over 2. There's a 2 here. ln 2 plus ln 4 is ln 8. All right, let me write that down for you. And this is going to be equal to, I just did one integration. I need to move my way out now. And that's going to be, let's see, ln 8 over 2, and then e to the minus v over 2 dv. All right. Now, that looks also pretty easy to do, and let's go through that. All right. You get ln 8 over 2. E to the minus v over 2. And then, you know, certainly when you differentiate that, you'd get minus 1/2. So I got to multiply by minus 2. The limits of integration go from 1 to 4. All right, I got to write this down now. ln 8 over 2. Oh, you know what? Let me simplify that. And probably a good idea to simplify it. All right, I noticed that the 2's cancel, so you really get minus ln 8. All right, so I'm combining this stuff over here. And let's just do this evaluation. So e to the minus 2, and then it's going to be minus e to the minus 1/2. All right, that's really my final answer, but I'm going to probably maybe simplify a little bit. And I'm going to write it as the natural log of 8. I'm going to write the e to the minus 1/2. Again, I pulled out a minus 1, by the way. So 1 over root a, and then plus 1 over e squared. Right, I want to keep rewriting it. Again, don't feel obligated to do so unless you really want to make it nice and neat. So I'm going to write down ln 8. And then I'm going to rationalize that first, guys. So it's going to be e root e plus 1 over e squared ln 8 e squared, common denominator. And then what do you get? You get e root e plus 1. Put a box on it. Again, mistakes happen. That's why we give you an answer key to look at it. I know my chicken scrolls all over the place, but I'm looking at this final answer over here, and I made a mistake. I see it now. Someone says, what's the mistake you made? I didn't do something, and I want to correct it for you, all right? So what am I going to correct? I said I factored a -1, and then when I did that, I forgot to put a minus sign over here. And let me put that over here, get the eraser out again. It's a mistake, but not a catastrophic one. Unless, of course, it has meant something as a computational problem, then it might be catastrophic. Let's take a look at it, see if we got it. And I'd always use a computer to check myself anyway. I really do mean that. I have a hard time trusting myself. You know, ln 8, I do see that. E root e minus 1 over e squared. Things are working as advertised. What do you mean by checking is, you know, using a computer algebra system to see if you get the same answer. So people say that says log 2. It's ln 2. What they do, 8 is actually 2 cubed, and they just pulled a 3 out. They're getting the same answer, by the way. Thank you.